Here's one of the many diagrams you can find online. This is from one of the data sheets. They all vary slightly, but they're pretty similar in what they are saying about getting a voltage out of the LM338. In order to do that, you have a voltage divider, and the ratio between R2 and R1 appears in this formula. You add 1 to that ratio, you multiply it by Vref, which is 1.25, and then you add it to this adjustment current multiplied by R2. I'm assuming that if R2 is quite large, then the effect of this adjustment current on V out is quite small. So given that, you know, in the boxes there's lots of different types of resistors in terms of the amount of resistance, how do you go about choosing one that's going to give you a V out that's going to suit your needs? Whether it be, well, in my case it's 3.3 volts, 5 volts and 12 volts that I'm looking at. So in order to find that out, firstly I went to a fairly typical AliExpress listing where you can buy, you know, in this case 130 values. These are quarter watt resistors, and again I guess that's another decision I need to make about what is going to be the power rating of those resistors in this scenario. And then there's a listing on the site which shows all the different values that you can have for that package. So I'm assuming that I've got, you know, a very similar list of resistors in the buckets. So what I did then was to write a little bit of code in Python, and all it does really is it has a listing of R1 and a listing of R2. It asks the user for the voltage that's required, and then an interesting one, which is the percentage accuracy, like how close do you want to get to that voltage. What it does then is it works out the ratio by just rearranging that equation, and then it just multiplies that ratio by the accuracy that the user was after. The real work's done down here, so it basically says go through all of R1 and go through all of R2. If R2 is greater than R1, do a division, and then if the absolute value of the division of J divided by I, subtract the ratio that we're looking for is less than the accuracy sort, then just print out that. Okay, so what does that mean when we're running this? So we'll start with an easy one, 5 volts. So if we do 5 volts and we want it to the percentage accuracy of, let's say, 1%, then we get all these kicked out from these lists here. And like I was saying, I'd probably choose larger values so that the adjustment current multiplied by R2 doesn't throw out V out by too much. So for instance, in this case, I might choose something like 300K for R2 and 100K for R1, and that gives 5 volts. So that's pretty good. Let's go down to 3.3 volts. This should be an interesting one. So 3.3, and we'll go to, let's say, 1% accuracy. And again, there's quite a few options kicked out. So I'd probably try something like maybe something like 330K for R2, 200K for R1. If you don't have a 200K, of course, a couple of 100Ks in series will do that. That gives you 3.31, which is pretty good. Let's go for the 12 volts. So we go 12 volts and we look for a 1% accuracy. There's nothing that's kicked out for that in amongst at least this list anyway. So we'll try that again at a 2% accuracy. Yep, and there's a few that are given. So if we want to go close, this is probably 11.83, and we've got 330K and we've got 39K, giving us that that option. So yeah, that's pretty useful to work out from the resistors that I have available what to use in that combination to produce the voltages that I'm seeking for the PSU. So at one stage in this project I was looking at the LM3805, but there's some current limitations with that, and so I went with the LM338 in the end, and that's rated presumably in the datasheet anyway to 5 amps. And Another thing which I was doing was chasing exact values for the resistors, and worked out pretty soon that all that meant was that you were chasing your tail most of the time, uh, because as soon as you change these resistors, then that extra little bit of current coming out of the adjustment pin on the LM388, 338, can actually have an effect on the output voltage anyway. So having a variable resistor in there is actually in the end the smartest thing to do. So that's what I went with. One thing which I haven't really figured out was, I still haven't figured out really, a couple of things about the resistor, or the voltage divider. The ratings for the actual resistors themselves. So at the moment that's 1/4 of a watt. I don't have a lot of half watt or 1 watt resistors, so I have got some on order. Whether that makes a difference or not, I don't know. And the other thing is that if the ratio between these two is 3 to 1, doesn't matter whether this is a matter of ohms or tens of kilo ohms. I'm not really sure, so I'm still doing some experimenting with that as well. Wasn't able to get the voltage indicator here in line with the digital multimeter for any length of time. You can adjust this, but the problem is that it does drift a fair bit, so it's not that accurate. And one really weird problem that I got in the end too is that if the current increases, then something happens with this device, that if it's not current limited, it provides like really weird voltage variations and current variations, which isn't good. So I'll show you what that looks like, and yeah, hopefully I can work that out, because I do want to have a power supply unit that can draw, let's say 2 to 3 amps if I'm doing something with, let's say, long LED strips, for instance. But I'll show you that weird effect, and yeah, we'll go from there. So the ZK4KX here is set to 8 volts, but is jumping all over the place. I think the current limitation is set to 0.5 amps, but it's well under that, and it just keeps flicking on and off. Initially, I thought there was something wrong with the circuit. It's a 3 watt LED with a heatsink underneath, and this is 10 ohm resistor. But you can see it's really having a really tough time. And so what I did was I thought, okay, so what if it's actually this thing here? So I swapped this out, and if I put in just a couple of lithium batteries here, so that's V in here, this should be around about 8 volts as well. But you can see a very different result from the batteries as opposed to the switching regulator. Makes me think maybe I need to read the manual, so I'll do that. And because this is nice that it can draw the current, so the circuit itself is sound, but I need to be able to draw, I think this is rated for 3 amps, so getting at least 1 or 2 out of it should be possible. So I'll read the manual and come back. The only other thing really that I need to do is to have a look at getting an indicator LED to show that this particular output is on. So in the final design there'll be a 12 volt, a 5 volt, a 3.3 volt, and a variable one, and I'll flick a switch, but I'll also need to have an LED indicator showing that they're on, and connecting that up to the actual circuit. Well, I don't want to draw a lot of current, and I certainly don't want to affect the voltage too much by having an LED in there, so I was thinking about having some sort of transistor switch for that. Anyway, let's have a look at this. I'll go away and do a bit of reading, and I'll come back and hopefully be able to maybe arc up that current a little bit. Well, even better news, not. So this is another DC to DC converter. So I've got my 19 volts coming in from the laptop power supply. And I do have 8 volts coming out, but the only way I know that is to measure it, because the screen is completely cracked and broken. Great. So maybe I can get a replacement screen. I'll talk to the suppliers, but that's not good. In the meantime, though, I don't know why, still keen to find out if
if the problem with the other one was something which is related to the circuit or something which is related to this device. I have ordered another one of these. I don't know why, but anyway, what I'm going to try and do is to see if this one was exhibiting the same problems. That is, if I do happen to have some high current going through, will that be a problem? Let me just fix up that drift in this tiny pot here, which is not great. I'll probably use a multi-turn pot in the final version with a lot more accuracy than this guy. So let's get him back to just over 5. Not too bad. And what we'll do is, and it jumps to 4.97, of course it does. So we'll take this out and we'll pop in our 10 ohm resistor and our ginormous 3-watt LED. So that guy there and here, and we'll see what happens. Alrighty. So there you go. Interesting. So something definitely going on with the circuits. The only thing I can think of is some sort of, I don't know, is there a problem with having one switching regulator feeding, which is the AC to DC, feeding into the second one. So that's interesting. So maybe not such a problem with this, maybe is a problem with the circuit. One thing I'm going to do is actually swap out that resistor for a 20 ohm and see if that makes much of a difference as well. All right, let's go the 10R again. 10 ohms, problem, and in fact, yeah, real problem. Okay, that's not too burny. All right, let's try again. All right, so it's back up and running. So there was some sort of current limiting going on there. Some sort of protection circuit kicked in. That's 20 ohms and gone. Okay, let's try higher. 100 ohms. Voltage reduction, interesting. Let's just turn it off again. So that voltage did drop. Not sure what current it's drawing. 4.97 to, oh, no, it's quite happy. 100 ohms. So yeah, not a lot of current being drawn there. Try something in between. So if I can get a 47, here we go, halfway, 47. Turn that guy off. Yep, it's coping with that okay, but not the 22. Interesting. Not really sure what's going on there. The LM338 isn't that warm. And because of the display, I can't even tell what current's been drawn. I'm going to swap this guy back in again and we'll try that. All right, not that I'm angry or bitter, but it wasn't this, well, we can't see. There we go. Oh my God. It wasn't the switching power supply at all. It was the laptop power supply, the AC to DC, that's at fault. So I'm bringing this in from a steady couple of 18650 lithium cells at just over 8 volts. This is regulating to 8, and we're drawing here, 0.255 amps, and everyone's happy. So interesting. What I might do is I might switch in another laptop supply and see if that's going to actually solve the problem. And just for those who've been screaming at their screens for the last few minutes, I've swapped out the power supply, and here we go, stable at 0.25 amps, not a problem. So yeah, I'm not sure what the power output that is. I think we can get that. 2 watts. So yeah, I'm pretty happy with that. So power supply issue all the way along, which I should have spotted way back when I first tested the output from that power supply, because it was jumping all over the place. And now we are back on track again for the PSU. So good. Probably the only bummer in the whole thing was in testing this guy, which is supposed to be a higher spec than the old ZK4KX, but as it turns out with a cracked screen, yeah, we're going to go back to that one, and I'm pretty happy about that because this is the one that I've designed the 3D printed box around, and I didn't really want to have to go back and do a redesign for this. Anyway, that is the circuit working. Happy days at the end of all of that, and yeah, we'll see you next time.